In this video, I'm going to take a look at Part A of Problem 8 in Chapter 11, Exercise 2. If a pair of dice are rolled, what's the probability that points add up to, for Part A, exactly 5? And unless otherwise noted, we're going to assume that all dice are standard Monopoly-style six-sided die. This problem is both an AND problem and an OR problem. So we've got to merge a couple of equations together here, and this really is as deep as we're going to go into Chapter 11. If you can get the various parts of Problem 8, you're probably in pretty good shape in terms of, test number 5. It's an AND problem, it's an OR problem. Let's begin here by going through the possible combinations to get a point total of 5. We're going to roll a pair of dice, and we want the numbers to add up to exactly 5. So to get 5, there's several different combinations here. We might get a 2 and a 3, in which case 2 plus 3 obviously is 5. Or we could get a 3 and a 2, or we could get a 4 and a 1, or, and I'm running out of room here, or we could get a 1 and a 4. So there are 4 different ways to make a 5. So let's break this up into little sections here. What's the probability of getting a 2? And again, we're going to assume that it's a standard six-sided die here. For this, we can use the classical theory. If we want a 2, there's one favorable outcome. We actually roll a 2. And it's a six-sided die, so there are 6 possible outcomes. The probability of getting a 2 would be 1 out of 6. What's the probability of getting a 3? Well, this 2 would be 1 over 6. And in fact, that's going to be the case for all of these. Probability that the first die becomes a 3 is 1 over 6, 1 over 6, and this part of it is quite repetitive. But 1/6 for all of these. Now to get a 5, one possible way again is a 2 and a 3. So this, of course, would be an AND problem. One way to get a 5 would be to get a 2 and a 3. The probabilities here are independent. The first die coming up a 2 doesn't have an impact on the probability of getting a 3. So here we're going to use restricted conjunction, which would just have us multiply these. 1/6 times 1/6, which of course would be 1 over 36. And that's going to be the case for all of these. What's the probability of getting a 3 and a 2? It's an AND problem. The probabilities are independent. So 1/6 times 1/6, which would be 1/36. And again, kind of repetitive here. It's going to be the case for each of these. 1 over 36. So there's the AND problem. We want a 2 and a 3, we want a 3 and a 2, we want a 4 and a 1, we want a 1 and a 4. Now the OR part. We want a 2 and a 3, or a 3 and a 2, or a 4 and a 1, or a 1 and a 4. So again, see clearly here that it's an AND problem, but it's also an OR problem. We're merging equations together. We've already done the AND part. 2 and a 3, 3 and a 2, 4 and a 1, 1 and a 4. Here's the OR part. 2 and a 3, or 3 and a 2, or 4 and a 1, or 1 and a 4. So the second part of this is obviously an OR. And the final question here, we're going to roll a pair of dice a single time. We want them to add up to 5. Are these events mutually exclusive? For the events to be mutually exclusive, that just simply means that they all can't occur. Mutually exclusive kind of sounds fancy, but they all can't occur. So we're going to roll this pair of dice a single time. Can all of these occur? Well, at best, rolling a pair of dice once, at best we can only get one of these. So that identifies our final equation. We are going to simply add these together. It's an OR problem. They're mutually exclusive. The second part of this is restricted disjunction. And the math here, not terribly important for this class. It's actually pretty easy. we're going to add these together. 136 plus 136 plus 136 plus 136 obviously gives us 4 over 36. Let me squeeze that in there. That'd be our final answer, 4 over 36. And I'm just fine with that answer. If you want to reduce it, that's fine. But 436 is good enough. So this is our trickiest problem yet. It's both an and problem and an or problem. We had to merge a couple of equations together here. Restricted disjunction where we're adding them, restricted conjunction where we're multiplying them, and of course practice here. This was problem 8 from chapter 11 exercise 2, but we just did part A. There are multiple parts here. Practice. If you can handle a problem that requires merging a couple of equations together like that, you're good to go.